Hey everyone, welcome to this review of all types of chemical reactions that we've learned so far in chemistry. So we're going to go over double replacement, synthesis, decomposition, and single replacement reactions here in this video. So first, this is just review. This is what we did before winter break. This is double replacement reaction, synthesis, and decomposition. So just make sure you still understand them, and if you're confused, please reach out. I'm happy to Zoom with you. So in a double replacement reaction, we have this general form of AB plus CD gives AD plus CB. And what happens is you are always going to pair up a cation, which has a positive charge, with an anion that has a negative charge. So how do we do this? Well, first of all, we switch our ions. We have the cations first and the anions second when we do this. So don't forget to do that. Always put the cations first. So, a hint that I told people in class was keep your cations. You know, I'm kind of a cat lady, so keep your cats, ha ha ha. Okay, so A here is a cation because it would have a positive charge, it would come first. C here is also a cation, it would have a positive charge, it would be written first. That's based on what we know about naming chemical equations. So keep A and C right where they are, but swap your anions. So keep your cats and swap your anions. Swap B with D, and you can see that done there. Then you're going to make sure you write the charges on those different elements. You get the charges from the periodic table. So you don't get the charges by guessing or anything like that. You look at the periodic table and then you balance your equation. So with polyatomic ions, it is a good idea that if you experience a polyatomic ion, either as a cation or as an anion, that you use parentheses when you begin working, and you can always get rid of them later if you end up with a subscript of 1, because you wouldn't put parentheses with a subscript of 1. So here's how they kind of look if you're more visual. It's kind of like two dancing partners and they swap. The person B swaps with person D in this. So that's an idea for double replacement. And here's a practice. So sodium phosphide and calcium sulfide. What I want you to do is actually get out a piece of paper and write this down as practice. Give it a try. If you are a hybrid student, note that we will do this one in class. But if you're an online student, please do this for practice. Please actually get out a piece of paper and write this down. Now, once you've solved it, see if you got the correct answer in the end. Here it is. If you got it wrong, please reach out to me. I would love to Zoom and help you understand where all of this information came from. All right, next, let's review diatomic molecules. Now, these are the elements that always exist in pairs. They're never alone. And there's a fun acronym to remember them. That's Brinkelhoff. So they are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And if you have any one of those elements by itself, just remember, it can never exist by itself. It always is either bonded to a different element or bonded to one of its own. So you can remember Brinkelhoff to remember those diatomic molecules, or you can remember that if you start at the 7th element, which is nitrogen, you make a 7 on the periodic table, and then you just remember that hydrogen is also included. So whether you remember it visually or by the acronym, it is your choice. Why do we care about that? Well, with synthesis reactions, we have elements that are joined together to make one product. So how do you do it? Well, you check the reactants when you write them, like A and B here are the reactants, and then when you put them together, AB would be the product. So you check the reactants to see if any of them are diatomic. If it is not diatomic, leave it alone. But if it is, please put a 2 as a subscript. Then you combine the metal and the nonmetal. Remember, always write the cation first and the anion second. Then you cross charges but just keep in mind, don't try to make the product a diatomic molecule. It's not. There are not going to be any diatomic molecules if you have 2 different elements bonded together. Just leave them bonded together. So you cross your charges on your product, and then you balance your chemical equation using coefficients. You can see an example is here with sodium and chlorine, and you can see it's like 2 individuals get together to make a couple. Here is a practice one. Please, if you are not hybrid, if you are 100% online, actually get out a piece of paper, write this one down, see if you can solve it, and then check your answer. If you are hybrid, we will do this in class. Did you get the right answer? All right, decomposition. Decomposition is when you have a compound and it breaks down into its elements. So on the reactants, which is a compound, you're going to cross your charges. And then how are you going to know the charges? Well, you use your periodic table to know the charges. Don't guess it. It's not some random numbers. Use the periodic table. The different columns will represent which charges those elements will have. If you do not remember that from way back in the end of October, please reach out to me. You need some help reviewing, and I will help you. But if you do remember, check on the periodic table, find out your charges, and cross them on the reactants. Then break the reactants apart into the elements that you see. Check the products, which are going to be individual elements, to see if any of them are diatomic. If they are diatomic, please put a subscript of 2, that is Brinkelhoff. Then balance the chemical equation using coefficients. You can see an example there. It's kind of like a couple splitting up. So if you're hybrid, you don't need to do this. We'll do it in class. But if you are 100% online, please write this down, pause your video, solve it, and see if you get the right answer. Here it is. All right. The last type of chemical reaction that we studied, and we actually just studied it this week, and hopefully you've already watched Miss Cook's videos, is single replacement. So what happens here is you have 2 elements like or 2 different things. You have possibly one element and then one compound, and then they react to form a different compound and a different element. So for example, A plus BC equals AC plus B. So you see that C moved from being paired with B to actually being paired with A. So here are the steps. First, write the element symbols and the charges. So if A on the periodic table, whatever element A is, it could be like sodium, could be potassium, could be magnesium. If it has a positive charge, write a plus under it. Check B. If that has a positive charge, write a plus under it. Check C. If according to the periodic table, that would have a negative charge, write a negative under it. Then notice that when you do the swapping, you are always going to put a positive with a negative. You will not put 2 positives or 2 negatives together. So you're going to switch the ions, never putting 2 positives or 2 negatives together. You will always put a positive with a negative, a cation with an anion. Once you have crossed the charges for the elements that are bonded and checked for diatomic molecules, you will then be able to balance the equation. So here's an example. We have potassium plus sodium phosphide. So we wrote potassium, K, sodium phosphide, NaP. And then we notice, okay, potassium's positive, sodium's positive, and phosphorus is negative. And how did I know that? I looked at the periodic table. Then I swapped my ions. I put my negative phosphorus with potassium rather than being with sodium. So I just moved my negative ion to where the other positive ion was. So I'm just swapping whatever it is. I'm going to swap, and I'm going to put, if I have a positive and then a positive and a negative, I'm going to take that negative and move it over to where the positive is. Then I'm going to look at the charges, cross my charges, check for Brinkelhoff, and then balance the equation. Here is just another little diagram here. So what you can see here is we have a positive lithium, a positive aluminum, and a negative oxygen. So since lithium and aluminum are both positive charges and oxygen is the only negative one, we know that oxygen is going to move over and be with lithium. Because we're never going to put 2 positives together. Like, it would not have made sense to put lithium and aluminum together, but it would make sense to possibly move the oxygen over to the lithium because lithium's positive and oxygen is negative. So then we find our products. It's kind of like a dance partner dancing and one other guy comes in and kicks out one of them. And now that guy's on his own. So here are some practices. Again, if you are hybrid, we'll do this in class, but if you are online, please take out some paper and pause your video and try this one. And then check your answer. Okay, try one more like this. This is another example, potassium plus calcium sulfide. If you are hybrid, we will do this in class. If you are online, please take out paper and try this. And check your answer. If you are at all confused on these problems, please reach out to me. I would love to Zoom with you and help you out. These are sometimes challenging, especially with having a 2-week long winter break. And I know you might need to review and practice some more. This absolutely requires you to maintain your knowledge of balancing equations, naming equations, and the different types of chemical reactions. So if you're lost, please reach out. I'm here to help. Have a great day.